Hello guys, welcome to Maths by Bodania sir. In this video, we are going to solve 5 important integration questions for class 12th board exams. I will explain the concept and solutions step by step. Don't forget to subscribe and press the bell icon to get updates on all types of questions, be it MCQs, case studies, assertion region, and descriptive 2, 3, and 5 marks. Pause the video, try the question yourself, then watch the solution. Let's start. In question number 1, it is saying that integrate this function with respect to theta. So firstly, what we can do is, if we change this cos theta into sine theta, cos square theta is 1 minus sine square theta, and then we can use substitution method. If we put sine theta is equals to t, then cos theta d theta will be equals to dt. Okay, so firstly we will change this cos square theta in sine theta. That will be 3 sine theta minus 2 into cos theta upon 5 minus 1 minus sine square theta minus 4 sine theta d theta. Okay, from here we can write 3 sine theta minus 2 cos theta upon 5 minus 1 plus sine square theta minus 4 sine theta d theta. Now from here we can write this 3 sine theta minus 2 into cos theta upon 4 plus sine square theta minus 4 sine theta d theta. Now let's sine theta is equals to t. Now we will differentiate both sides with respect to t. So sine theta will change to cos theta. Again we will differentiate theta with respect to t. That will be d theta by dt. Here differentiation of t will be 1. From here we get cos theta d theta is equals to dt. In further questions, I will directly write this wherever a substitution will be required. Clear? So from here I can write that now we know that sine theta is equals to t, that is 3t minus 2 upon 4 plus t square minus 4t, and this cos theta d theta will be equals to dt. So we will write this dt. Okay, so now we can write this as 3t minus 2 upon, this can be written as t minus 2 whole square dt. Clear? Now what we have to do is use partial fraction. So let's say 3t minus 2 upon t minus 2 whole square is equals to a upon t minus 2 plus b upon t minus 2 whole square. Okay, here for better understanding, I am writing which type of partial fraction is this. So it is of the form px plus q upon x minus a whole square. So now we can write it in form of partial fraction of the form a by x minus a plus b by x minus a square. And this is what I have used here. Getting the point? Okay. So now let's find the value of a and b. So taking LCM, we will get this is 3t minus 2 upon t minus 2 whole square equals to, here LCM will be t minus 2 whole square, and this will be a into t minus 2 plus b. So this will cancel out, and from here on further simplifying we will get 3t minus 2 is equals to at minus 2a plus b. So now comparing the coefficient of t is 3, on the right hand side it is a, so a is equals to 3. Next, minus 2a plus b is equals to minus 2. So we'll write minus 2a plus b is equals to minus 2, and the value of a that we know, that is 3. So it will become minus 6. On taking it to right side we will get plus 6 minus 2, that is 4. So b is equals to 4. Okay. Now we can easily use these fractions for integration. Now we can write this integration, that is equals to integration of a is 3 upon t minus 2 plus b is what, that is 4 upon t minus 2 whole square and dt. So from here we can integrate these two parts separately. So we can write 3 upon t minus 2 dt plus integration of 4 upon t minus 2 whole square dt. So from here 3 will be as it is 1 by t minus 2, and integration of 1 by t minus 2, it's linear expression. So directly we can write log mod t minus 2 plus 4 will be as it is into 1 by t minus 2 square. This is basically square of linear expression. So we can write this as t minus 2 minus 2 dt. So from here we can write log t minus 2 plus, now integrating this, what we will get, we will get 4 t minus 2 minus 2 plus 1, that is minus 1 upon minus 1, and here we will write c. Now what we can write here is that is equals to 3 log mod t minus 2 minus 4 upon t minus 2 plus c. Now we know that t was substituted for the sine theta. So in place of t, we will write sine theta. So from here we will write that is equals to 3 log mod sine theta minus 2 minus 4 upon sine theta minus 2 plus c. This is the answer. Okay. Okay, question number 2 is asking integrate 1 upon this function with respect to x. Okay, here we can see that we can easily integrate it by completing the square method. So on completing the square method, we will get what? That is, let's say dx. What I'm doing is I'm taking minus common from here. Okay, so minus upon, it will become x square plus 8x minus 5. Now completing square, for that what we have to do is we have to half the coefficient of x, that is 8. So we'll get x plus 4 whole square, and now what we have to do is minus the square of 4, that is 16, and from here we will get minus dx upon x plus 4 whole square minus 21. Okay, so now we can write this as dx upon x plus 4 whole square minus under root 21 whole square. So now we can use the formula, since integration of dx upon x square minus a square, that is equals to 1 by 2a log mod x minus a upon x plus a plus c. Okay, so here we can see that this is linear expression in x, so we can directly write as this is equals to minus 1 by 2a. A is what? That is under root 21. So under root 21 log mod x minus a. So here x is x plus 4 minus a is 21 upon x plus a, that is x plus 4 plus root 21 plus c, and this is the answer. Clear? Next, question number 3, it is saying that integrate this function with respect to theta. Again, what we can do here is we can change this cos theta into sine theta, and again taking sine theta equals to t. So we can write it as integration of cos theta upon 4 plus sine square theta into 5 minus 4 into 1 minus sine square theta d theta. Okay, so from here we can write it as cos theta upon 4 plus sine square theta into 5 minus 4, that is 5 minus 4, that is 1 plus 4 sine square theta d theta. Okay, so let's say let sine theta is equals to t. So from here we will get cos theta d theta is equals to dt. Now I have explained this step elaborately in question number 1, you can go and see there how we have reached here. Okay, so from here what we can write is, in place of cos theta d theta we will get dt. So we will get dt upon 4 plus t square and 1 plus 4t square. So now we are going to use integration by partial fraction. So we can write it as 1 upon 4 plus t square into 1 plus 4t square is equals to a upon 4 plus t square plus b upon 1 plus 4t square. Okay, now taking LCM on right side, denominator will get cancelled out and we will get 1 is equals to a into 1 plus 4t square plus b into 4 plus t square. From here 1 is equals to a plus 4at square plus 4b plus bt square. Now taking t square common from both these, we will get t square 4a plus b plus a plus 4b is equals to 1. So this is the constant part and this is the coefficient of t square. So from here we can write it as 4a plus b is equals to 0 because on right hand side we don't have any coefficient of t square, and a plus 4b is equals to 1. From here we can write a is equals to 1 minus 4b and substitute this value in this to get the value of b. So from here we will write 4 into 1 minus 4b plus b is equals to 0. So we'll get 4 minus 16b plus b is equals to 0, and we will get what, 15b is equals to 4 and b is equals to 4 by 15. From here we can find the value of a from expression 1. So it will be 4a plus 4 by 15 is equals to 0. So a will be equals to minus 1 by 15. Okay, you can write the integration as a by 4 plus t square dt. So a we have found that is minus 1 by 15 integration dt upon 4 plus t square. We can write 4 as 2 square plus t square plus b is what, 4 by 15 integration dt upon 1 square plus 2t whole square. Now we can easily use the formula of integration, that is integration of dx upon x square plus a square, that is equals to 1 by a tan inverse x by a plus c. So we know that this form is x square plus a square, and this is also in the form x square plus a square. So from here I can write minus 1 by 15 into 1 by a. 1 by is what? A is 2. So we will get 1 by 2 tan inverse x is t by 2 plus 4 by 15 into 1 by a. A is 1. But here what we are having 2 as a coefficient of t. So we have to divide this by 2. So 4 by 15 into 2 into tan inverse x by a. X is 2t by 1 plus c. Okay. So from here I can write 1 upon 30 tan inverse t by 2 plus. So now we can cut 2 to the 4. We will get 2 by 15 tan inverse 2t plus c. And as we know that we have taken sine theta as t, so in place of t we will write 1 by 30 tan inverse sine theta upon 2 plus 2 by 15 tan inverse 2 sine theta plus c, and this is the answer. Clear? Okay, next question number 4 is from definite integrals. Question is saying integrate this function from 1 to 4 with respect to x. Okay, so we know that in different intervals between 1 and 4, this modulus function will behave differently, because inside the modulus function, if the value becomes negative, then modulus function will open with minus sign, and if it is positive, then it will open as it is. So firstly, what we have to do is we have to define the function in different intervals. So here firstly we have to find critical points. So for critical points, we know that x, what we have to do is put x minus 1 equals to 0, x minus 2 equals to 0, x minus 4 equals to 0. And what are critical points? Critical points are those points where function changes its behavior. So here x minus 1 equals to 0, so we get critical point x equals to 1. Next, x minus 2 equals to 0, so we get x equals to 2. X minus 4 equals to 0, so we get x equals to 4. Okay, so now what we do, we draw a number line and put these points on the number line, that is 1, 2, and let's say this is 4. And what we have to do is find integration from 1 to 4. So first interval is from x is greater than equals to 1 but less than 2. So here we will get fx. Now what is fx? Fx is this whole function we are saying, that is fx. Okay, so if we put any value between 1 and 2, what we get, that x minus 1 is always positive, so modulus will open without any sign, so x minus 1 will be as it is, plus, now since the value is less than 2, so x minus 2 will be negative. So here we will open the bracket with the minus sign, so we will get minus x minus 2 plus, again if the value of x is between 1 and 2, then x minus 4 will be negative, so we will open the modulus with negative sign, so minus x minus 4. So here fx becomes x minus 1 minus x plus 2 minus x plus 4. We will get, so this will cancel out, so we will get 4 plus 2 6 minus 1 5 minus x. So between 1 and 2, the function will be 5 minus x. Now second interval, we know that that is 2 to 4. So next will be fx, that is equals to, we are defining x that is greater than equals to 2 but less than 4. Now first is modulus x minus 1. So x minus 1, between x between 2 and 4, this will always be positive, so we will write this as it is, x minus 1. Now between 2 and 4, x minus 2, since x is greater than equals to 2, this will also be positive, so we will write it as it is, x minus 2. But here x is less than 4. Okay, so for less than 4, x minus 4 will be negative, so we will write it as minus of x minus 4. So here second function is x minus 1 plus x minus 2 minus x plus 4. Again x will cut this x, and this is x minus 1 minus 2 minus 3 plus 4, that is plus 1. So for interval between 2 and 4, we will be getting the function x plus 1. So now we have clearly defined the function, so we can write that, let's say I is equals to integration for x from 1 to 2, the function will be 5 minus x dx, plus from 2 to 4 it will be x plus 1 dx. Now we will integrate it. So here we will get I is equals to 5x minus x square by 2, 1 to 2, plus x square by 2 plus x, that is 2 to 4. So I is equals to, first we will put the value of x equals to 2, so we will get 10 minus 4 by 2 minus, now we will put the value 1, so we will get 5 minus 1 by 2 plus, now we will put the value 4, that is 16 by 2 plus 4 minus, now we will put value 2's, that is equals to 4 by 2 plus 2. So from here I is equals to, we will get 10 minus 2, that is 8, minus 5 plus 1 by 2, plus from here we will get 16 by 2, that is 8, plus 4, minus 2 to the 4, that is 4. So 4 will cut, and from here we will get I is equals to, taking 2 as LCM, 16 minus 10 plus 1 plus 16. From here we will get 16, 32, 33 minus 10, that is 23 by 2 is the answer. Clear? Okay. These modulus type of integration are repeatedly asked in board exam. So practice these type of questions a lot. Okay. Next, question number 5 is also from definite integrals, and this is saying integrate this function from 0 to pi by 2 with respect to x. Okay, let's say this integration is I, this is 0 to pi by 2 x sine x cos x upon sine to the power 4x plus cos to the power 4x dx. Now what we are going to do is use definite integral property, that is fx dx from a to b is equals to a to b. Instead of x we can write a plus b minus x dx. Clear? We are going to use this property. Now again I is equals to 0 to pi by 2. Now instead of x in this function we will write pi by 2 minus x, because 0 plus pi by 2 is pi by 2. So we will get pi by 2 minus x into sine pi by 2 minus x cos pi by 2 minus x upon sine to the power 4 pi by 2 minus x plus cos to the power 4 pi by 2 minus x dx. So from I is equals to 0 to pi by 2, and we will get pi by 2 minus x. Now sine pi by 2 minus x is cos x into cos pi by 2 minus x is sine x upon, instead of sine pi by 2 minus x will be cos to the power 4 x plus sine to the power 4 x dx. Now let's say this is 1 and this is 2. So now we are doing what? 1 plus 2. So on doing 1 plus 2 we will get on the left hand side, that is 2i, and on the right side what I am doing is I am taking this part as common from both. So we will get what? X plus pi by 2 minus x. So from here we will get 0 to pi by 2, that is x plus pi by 2 minus x into sine x cos x upon sine to the power 4x plus cos to the power 4x dx. Now x will cut x, so we will get 2i is equals to, now pi by 2 is constant, we can take out it from integration, that is pi by 2, 0 to pi by 2. Here we will get sine x cos x. Now from here, now what I'm doing is I'm changing this cos to the power 4x into sine x. So I can write sine to the power 4x plus 1 minus sine square x whole square dx. We know that 1 minus sine square x is cos square x, and cos square x whole square, that is cos to the power 4x. Same. Okay. So from here we can write 2i is equals to pi by 2. Why I am doing this? Because after this we can substitute sine square x equals to t, and we will get sine x cos x dx equals to dt by 2. That's why I am changing this cos into sine. So from here 0 to pi by 2 sine x cos x upon sine to the power 4x plus 1 plus sine to the power 4x minus 2 sine square x dx. Okay, so now let's substitute. Let sine square x is equals to t. On differentiating both sides with respect to x, we will get 2 sine x cos x dx by dt is equals to 1, and we will get sin x cos x dx is equals to dt by 2. So in place of this we will put dt by 2 and accordingly proceed. Now as we have changed the function in x to t, so what we have to do is we also have to change the limits in t, because initially the function was in x, so these limits are for x. Now what we have to do is to change these limits into t. So we can write that if x equals to 0, then we will get t is equals to what? Sine square 0 is 0. T is equals to 0. Now upper limit is pi by 2. So if x is equals to pi by 2, so we will get t is equals to, in place of x we will write pi by 2. So sine square pi by 2, that is 1, that is t is equals to 1. Now we can write the above integration in terms of t. So I can write I is equals to, what I'm doing is I'm taking this 2 from 2i to the right side, that is pi by 4 0 to 1. Now limits have changed since we have changed the function from x to t. So instead of sine x into cos x dx, we will write dt by 2. So 2 will come out of the integration and it will multiply with 4. So we will get pi by 8 and dt upon, now sine to the power 4x plus sine to the power 4x, we will get 2 times of sine to the power 4x, or instead of sine to the power 4x we can write sine square to the whole square. So we can write t square minus now 2 sine square x, so we will get 2t plus 1. Now we can see that we can integrate this very easily by doing what? By completing the square of denominator, and then we will get the standard form, and using the formula we will integrate this. So now we can write that I is equals to pi by 8. Now what we have to do is we have to take 2 common from this, because t square coefficient should be 1 for the completing square method. So taking 2 outside, what we will get? Pi by 16 integration 0 to 1, and this is dt upon, we will get t square minus t plus half. Okay, now completing the square, pi by 16 0 to 1 dt. Now what we have to do is we have to half the coefficient of t, that is minus 1, so we will get t minus 1 by 2 whole square plus 1 by 2 minus 1 by 2 whole square. So from here I is equals to pi by 16 0 to 1 dt upon t minus half whole square plus 1 by 2 minus 1 by 4, that is 1 by 4. Here we can write 1 by 2 whole square. Now we can easily integrate this form using the formula. Which formula? We know that since integration of dx by x square plus a square is equals to 1 by a tan inverse x by a plus c. So we will apply this formula here. So we will get I is equals to pi by 16. Now 1 by a is what? That is 1 by 2. So 1 upon 1 by 2, that will be 2 tan inverse x is what? T minus half, that is t minus half upon a is half. Now we will put the limit 0 to 1. Okay, now putting upper limit, we will get pi by 16 2 times of tan inverse, putting 1 we will get 1 by 2 here, 1 by 2 1 by 2, that is 1, minus, now putting the lower limit, we will get 2 times of tan inverse, putting 0, that we will be getting tan inverse minus half upon half. Okay, that is minus 1. Okay, so from here we will get I is equals to pi by 16. 2 times of tan inverse 1, we know that tan inverse 1 is pi by 4, minus 2 times of tan inverse minus 1. Here we got minus 1, so tan inverse minus 1 is minus pi by 4. So this is minus pi by 4. So from here we can write I is equals to pi by 16. This is pi by 2. Minus minus will be plus pi by 2. That is equals to I is equals to pi by 2 plus pi by 2 is pi. We will get pi square by 16. This is the answer. Getting the point? Okay. Okay, here we end the video. If you like the video, hit the like button, share this video with your friends so that they can also get benefited. See you in the next video. Bye bye.